We'll pick back up with the next several questions, and we'll start at number 4 since we ended with number 3 in the first video. Driving through England and you find that you need gas. You are driving an American car and that you rented somewhere, and it holds 14 gallons. The control panel's information system tells you that you have 1 gallon left in the tank. Well, if you have 1 gallon left in the tank and it holds 14 gallons, then as you see in this first calculation here, you're going to need 14 minus 1. You'll need 13 gallons to fill the tank. So we want to convert that to liters to find out how much gas we're going to need in liters, because that's how they sell and price gasoline in England. And we are given a conversion factor in the question right here. It's 1 gallon equals 3.7854178 liters. So if this equation 1 equals 3.785, then we can multiply the 1 times 13 and the 3.785 times 13, and that'll give us how many liters we're going to need to purchase, and that's this calculation right there. 13 times 3.7854178 is going to be equal to 49.210353114. How far should you round it? Use your own judgment. I would accept 49. That's a reasonable answer. If, on the other hand, this had been 49.9, you'd probably round that up to 50. But use your own judgment there. And if you've done everything correctly, I won't penalize anybody for rounding, for how they choose to round. If you choose to round and you round incorrectly, that's a different matter. If you wanted to round to the units place, then in this place here, in the tenths place, you would round up if this value was 5 or greater. You would round down if it's 0 through 4. Alright, now in the next question we're asked to do another conversion, and we're canceling, we're converting one unit to another again, but this time it's not one single calculation, it's not one single conversion. There's several conversions. You're converting years to seconds. Years are comprised of a lot of seconds, so you have to make several multiplications. And you'll want to make what I call keep multiplications with keep-cancel fractions. Now, why do I call them that? Well, whatever units you're keeping go in the numerator, and whatever units you're canceling go in the denominator. So, for instance, if you want to convert years to seconds, you might first convert to something shorter, that is days. So there's 365 days per 1 year, and so you multiply that. You see, this is just 1. 365 days and 1 year, those are the same thing, so this is just 1. And so when you multiply 50 times this, you're just really multiplying 50 times 1. And for convenience sake, to make the cancellations clearer, I have written the 50 years over 1 for the first fraction, multiply times 365 days over 1 year, and the years here cancel. Units cancel just like numbers do, and so years divided by years is just 1, so that cancels. Then we're still not anywhere close to seconds, so we're going to cancel, or rather we're going to convert, we're going to convert our days to something shorter. Next shortest unit I can think of is hours, so we'll multiply by 24 hours in 1 day. We're going to multiply by 24 hours over 1 day, because the day is what I want to cancel out of this fraction here. So I multiply 24 hours over 1 day, and days are the same units, and units cancel just like numbers do, and so that gets us one step closer. And continuing this pattern, I convert hours to minutes by multiplying by 60 minutes over 1 hour. The hours cancel. And then finally I convert to seconds by multiplying 60 seconds over 1 minute. So the minutes cancel here, the hours cancel here, the days cancel here, the years cancel here, and the units that are left are seconds. It's the only unit that's left. And so I come up with this answer. 1,576,800,000 seconds. But the question asks us to express this in scientific notation. So to do that, you place the decimal point right here to the right of the first digit in line. Place it to the right of the first digit in line. And then you count the number of units or number of spaces that you have to move the decimal to the right to get to the end. Well, we moved it, if you count here, there's 9 times we moved it. Moved it 9 times, and so that's what goes in this exponent right here, 10 to the 9th. So in scientific notation, this is 1.5768. The decimal place is here because that's where I have where I need to place it for scientific notation. So it's 1.5768 times 10 to the 9th. There's 9 places we moved the decimal, so this is going to be 10 to the 9th. And that's your answer in scientific notation. Now this question, the day that I explained it in class, I kind of made it a little more complicated than it really needed to be. Let me just say that the best way to handle this this conversion is to convert the distance, the numerator's units separately, and then whatever value you get, sort of set it aside, and then convert the the denominator. So the numerator is in miles, it's a distance, and convert the denominator from hours to seconds separately, and then divide the denominators, or the numerators units, by the denominators. So what's the numerator, what's the denominator? Miles per hour tells you that miles is in the numerator. The per is kind of this fraction line right here, and the hours are in the denominator. So we convert miles to meters, and we're given a conversion factor for that, 0.3048. We are not given this factor, 5,280 feet per mile, but I will have any, oh no, I guess we are right there. Sorry, beg your pardon. There it is, 1 mile is equal to 5,280 feet. So we convert the miles to feet, and then the feet to meters, just as we did in the last question, where we have units we want to keep in the numerator over units we want to cancel in the denominator. And so this first multiplication cancels the miles, and then the second multiplication cancels the feet, and so we wind up with 104,607.36 meters. Then we convert the hours to seconds, just like we did in the last question, and that's going to give us 3,600 seconds, 3,600 seconds. The numerator's units are the 104,607.36 meters. The denominator's units are the 3,600 seconds. Divide one by the other and you have 29.0576 meters per second. And I think that's as far as we'll go for this video. We'll move on to the next one for the next questions.